So we're continuing where we left off in the last video. We just found that the inverse function for velocity and kinetic energy, so v of e is equal to the square root of e over 4, where energy is greater than or equal to 0. So if we want to estimate the velocity required to have the kinetic energy of 60 joules, so we'll substitute 60 into our function. So we take our original function, v of e is equal to e divided by 4. We substitute 60 in for e. So this is just showing that 60 is now our input. We can simplify. I'm going to write it over here. So v of 60 will be the square root of 13. 60 divided by 4 is 13. And so then you can use your calculator. That might be 15. 15 makes much more sense. My writing is bad. I apologize. 15, not 13. You can use your calculator to find the square root of 15 to get an estimation of about 3.9. So an 8 kilogram object with kinetic energy of 60 joules is traveling at a velocity of about 3.9 meters per second. Here we've got a function. Area is pi r squared for the area of a circular object with respect to its radius. We want to write the inverse function to find the radius required for an area of a, then estimate the radius as an area of 40 centimeters squared. So we take our function, we replace a of r with just a, it's pi r squared. We need to divide by pi, and then we take square root. So we can rewrite our function as, sorry, that's not squared anymore. R of a is equal to the square root of a over pi. So that's going to be our inverse function. We can take our input of 40. Our area input was 40. And you can plug that into your calculator. The square root of 40 over pi is going to be approximately 3.6 units will be centimeters squared. We can also find the inverse of cubic functions. So the only thing that's different now is not x squared, it's going to be x cubed. So the inverse of a cubic function is a cube root function. It looks like this. It's got a little 3 out front there. So that's going to be what our cube root looks like. We do the exact same process, just instead of a square root, now it's going to be a cube root. Everything else stays exactly the same. So this is what the graph looks like for the problem they just solved. We're going to work through this one together. So we've got f of x equals x cubed minus 9. First thing we do, replace f of x with y. Now we add 9 to both sides. Now we take the cube root. We switch the letters. And then we rewrite it as f to the negative 1 of x is equal to the cube root of x plus 9. And as we've seen before, we can graph these. You can graph this in your calculator. Again, we're restricting our domain. Oh, no, we don't have to. Aha. With a cubic, we don't have to restrict the domain because you can have a negative be cubed and come up with a negative output. So with a cubic, we do not restrict the domain, only with something squared. So in this case, we will need the full graph. So it's going to look something like this. And then something like this. And if I would have done it correctly, it should have been reflected across the line, y equals x. Again, this is something you can graph on your own with your calculator. So here we want to find the inverse and graph a function in its inverse. So we have y equals 2x cubed. Our first step, replace f of x with y. Now we'll have to divide by 2. And now we take the cube root. We switch x and y. And our last step, we just rewrite it as f to the negative 1 of x. And that's our function. We can also use cubic models. So again, same situation. We're just using a cube root instead. It's the only difference. So here we've got the function a of r is equal to 4/3 pi r cubed. This gives the surface area of a sphere with radius r. So we want to find the inverse function. So our original function is a cubic because it's r cubed. So to find the inverse, we replace a of r with a. In this case, we divide both sides by 4/3 pi. So dividing by fraction, same thing as multiplying by the reciprocal. This is really 4 pi over 3. So we'll have 3 over 4 pi times a. Now we have to do the cube root. I'm going to write it over here because my window there is kind of small. So cube root of 3 over 4 pi times a. We replace r with r of a, and our inverse function then will just be cube root of 3 over 4 pi times a. So just one last problem to work through here. Function m of r is 44 over 3 pi r cubed, gives the mass in grams of a spherical lead ball with a radius of r centimeters. Find the inverse function to find the radius of r with a mass of m. So replace m of r with m. Now we need to divide by 44 over 3 pi. So again, this is the same thing as 44 pi over 3 r cubed. So we can multiply by the reciprocal. So we'll have 3 over 44 pi. M is equal to r cubed. We take the cube root. We'll have 3 over 44 pi. 3 over 44 pi times m is equal to r. And then just rewriting it, so we'd have r of m is equal to cube root of 3 over 44 pi times m would be our inverse function.